Do you know what's a math teacher's favorite kind of tree? Geometry.
8.54 Misleading population estimates. So let's make sure steps to check misleading population estimates. The first thing I want you to do is verify that the NP hat is greater than or equal to the margin of error, and the NQ hat, that's twice, is greater than the margin of error, or that's greater than or equal to, we use that number to be 5 before as well. And the second thing I want you to check is the confidence level. There's only 3 numbers. What are our 3 numbers for our confidence intervals? It's only 90, 95, and the third one is 99%. And we also need to check the interval. All right, let's take a look at example here, polls. So, the biggest use of statistics and population parameters is actually on voting day in November, voting for either Trump or Biden. And every year, even local elections, the biggest thing is using statistics to estimate with confidence, do we have all the votes? Because they don't have all the votes all the time until the very end. A lobbying group that supports the passing of a ballot measure releases a report based on a poll they performed. They claimed with a 90% confidence the proportion of people who will vote for the measure is 50%, but could be as low as 40% due to the margin of error of 5%. The sample size was 200. Identify any misleading representation in the data. All right, this is how I got P hat. P hat, if you add 5% to P hat and you get, say, 50%, right? Because if you do P hat minus the margin of error of 5%, that's the margin of error, E, think of it as E. So if we subtract 5%, we should get 45%. We should get a range of 45 to 55. Does this make sense? Let me highlight those 2 numbers. So if I know that it's 45, it has to be 45%. And I'll tell you why. Because if I add 5, I get 50%, because that's the high. And if I subtract 5, I get 40% as the low. So P hat is, let's make this clear, P hat is 45. Well, if P hat is 45, that means Q hat has to be 55, because they're complements to 1. So let's just check their conditions. 200 times 0.45 is 90, and that is greater than or equal to 5, and 200 times 0.55 is 110. So it does meet those conditions. Okay, let's go on to step number 2 now. Examine the confidence level. 90% confidence level is acceptable because you only have 3 numbers, 90, 95, and 99. Okay, now this is where it goes wrong. And let me write this in writing so you can kind of see it. However, instead of stating the population proportion is estimated to be 45%. With a margin of error of 5%. But their mistake, so let me write this in red, kind of like bad. Well, red's not bad, but I'm just trying to they state the highest possible estimate for the population proportion to give the impression the candidate is likely to obtain 50% of the vote. So even to use the words, they're saying 50% is the high or the upper end of the possible range that he'll get. But that's not true. It's at 45%, and it can go up to as high as 50, but as low as 40. But they should have focused on the number 45 as their point of estimate. Okay, directions. In questions 10 and 11, skip one problem below. If you want to see me do it with you step by step, then go ahead and just press play. Okay, question number 10. An employee at a restaurant conducts a poll about the satisfaction with their lunch menu. The report claims with 80% confidence that the proportion of people who are satisfied with the lunch menu is between 85 and 90%, and the sample size was 15. Identify a misleading representation of the data. Okay, let's first talk about 80% confidence. What do you think? This confidence level is too low. What are the numbers? Should be 90, 95, and 99%. What else do you notice? Sample size. If n equals 15, let's do some math. If our sample size let's just say is 87.5, p hat is 87.5, and I got that number is because it's in between the middle. Does that make sense? Because you're kind of adding and subtracting. That's subtracting that direction. You're adding that direction from the point of estimate, our sample proportion. So that's in between, 85 plus, let me explain that again. 85 plus 90 divided by 2 gives me 87.5. And if I take that number, n times p hat is greater than 5. N has to be, what did we say? 15 times 0.875. And is that greater than or equal to 5? Well, I get 13.125. It is greater than 5, but if I do the Q, so 15 people, and then 1 minus 1 minus 0.875 equals, Q would have to be 0.125. Is this greater than or equal to 5? So 15 times 0.125. This gives me 1.875, and this is what? False. It's not greater than 5. So there we can say our sample size is too small. Right? All right, question number 11. A recent poll showed that 120 citizens were in favor of building more parks in the community. The claim was made with 95% confidence, so that's okay. Right? 95% is one of our numbers. That the proportion of people who want to build more parks is 51%. But could be as low as 45% due to the margin error of 3%. The sample size was 250. Identify any misleading representations. Okay, so let's see. They said x equals 120. That's the favorite, right? And n here is 250. So p hat equals x over n, which is 120 over, that's a 0, 250. And if you do your math, this will get me 0.48 with a margin of error. So 0.48, p hat is 0.48, and that's in the middle. Because if you take p hat plus e and p hat minus e, you will get 0.48, and the margin of error was 3%. You'll get 0.45 and 0.51 or 51%. But what they're showing here, though, they're showing a high of 51% and claiming that as their highest possible estimate for the population proportion to give an impression that the proportion of people who wants the park is greater than 50%, but that's not the case. So the error is using the high estimate. Using the highest possible estimate as the population estimate. So in other words, it should be 0.48 rather than using just 0.51. Does that make sense? So they're just kind of using the wrong side of the spectrum. Well, that was lesson 8.50. We're talking about taking the sample data and making inferences about the population. Remember, think about that candy machine. You put in some quarters and you get some Reese's Pieces out of it, and the Reese's Pieces can tell us about all of the pieces in the candy machine. We'll see you guys later.
We doing math today, ain't got time for no games. We doing math today, all work and no play. We doing math today, listen up and behave. We doing math today, we doing math today.